Okay, so off we go. Couple of special right triangles to start us off, and then we start getting into quadratics. Okay, so special right triangle time. In any 45, 45, 90, we know that the two sides are the same, and the value of the hypotenuse was the length of those two sides multiplied by root 2. Now, keep in mind, to go this way, we multiplied by root 2. So that means if you're going to go the other way, that means you divide by root 2. So 12 divided by root 2. And you want to remember, we're not supposed to leave roots in the bottom. So that's going to be 12 roots of 2 over 2, because that was our strategies, multiply the top and bottom. And this reduces to 6. So 6 roots of 2 both times. Now, of course, in the 30, 60, 90, there was a slightly different pattern, and that was that the hypotenuse was twice the size of the shortest leg, and that the medium side was 5 times that square root of 3. So whatever the short leg is, multiplied by root 3. Now, again, what he did is kind of made this a slightly harder version. So to go this way, I multiplied by root 3, which means over here, we're going to divide by root 3. And just like that previous problem, we're going to have to simplify by multiplying by root 3 on top and bottom, which is 27 roots of 3 over 3, but that reduces nicely to 9. So we've got 9 roots of 3, and of course the hypotenuse is doubled, and so 18 roots of 3 it is, and we've got a nice looking answer. Now on to our quadratics. Now the first one isn't going to be too bad. The deal is if we wanted to complete the square, we'd have to take this value and cut it in half and then square it. So half of negative 16, negative 8. And if you square negative 8, you get 64. So this problem says find the value of c. Now that value of c would be 64, but that actually tells me that the perfect square would be x minus 8, okay? Now this problem actually asked for the 64, but we're going to use this in some other ones, so I thought I would bring that up. Remember, when you do complete it, this value, x squared minus 16x plus 64 would be this. And I'm going to use that in this next problem. So if I wanted to get this into vertex form, the personal strategy that I like to do is I group this almost like this problem right here, and I ask that same question. What value would complete this square would be 81. But mathematically, that's not a legitimate thing. I can't just add 81 to the right side unless I also add it to the left side. But equivalently, I'm going to choose to add 81 and take 81 away because obviously those would cancel out. So I haven't really changed the math. And that means this portion simplifies to minus 31. This perfect square is x plus 9. And so that's really awesome because that's vertex form. That means this problem would have a vertex of negative 9, negative 31. And of course, we could use our 1, 3, 5 pattern to graph it. And then last problem on this page is to solve this by completing the square. Now, we normally like quadratics to be set equal to 0, but in completing the square, we do something a little bit different. The first thing I'll do is add 13 to both sides. Now, again, just like we did before, we're going to cut in half and square, which adds 16 to both sides, which leaves x minus 4 squared is 29. This now set us up really, really nicely because if I take the square root of this side, I get x minus 4. The square root of this side, remember, it's plus or minus anytime you do that. And the only thing left to do is add 4 to both sides. And so x becomes 4 plus root 29 or 4 minus root 29. And those are the two answers for that particular quadratic. All right, moving on just a little bit more. We'll just do a couple more. Let's take a look at number 19 and 20, and then we'll stop this one. The vertex of this thing, it's already sitting in vertex form, so it has been shifted to the left 5 and down 13. Since that was already there, that's pretty easy. And the last one for this video, finding the roots of the problem. The roots is equivalent to saying find out when y is 0. So what I see is let's move the 18 to the other side by subtracting it. And I think most of you would probably realize we would want to divide by -2 to make this a little bit prettier. And we have a pretty nice answer now, because when we take the square root of both sides, as we've done on some of the previous problems, the square root of x plus 5 squared is x plus 5, and this is plus or minus 3. And of course, to complete our isolation, take away 5. 3 take away 5 is -2, and -3 take away 5 is -8. And hey, that ends that particular video. And so I will see you on the next one for problems 21 and down. All right, see ya.